A library surveys 20 borrowers each day from Monday to Friday and records the number who are not satisfied with the range of reading material. The results are 3, 7, 6, 8, 11. So that's the number of people out of 20 surveyed who said that they're unhappy with what the library is offering to read. The following year, the library receives a grant that enables the purchase of a large number of books. The survey is then repeated and the results are 2, 3, 5, 4, 6. They've done the same sort of survey, 20 people again, asked them on 5 different days, 20 people hopefully selected in a good method, using a good method, and there's different results. So what we need to do is find the mean and standard deviation for each survey using the formula. So I've got all the formulas below, which I'll talk about in a minute, and using technology, which is where you use the stats function on your calculator. In the future, I don't really want you to be using the formula. I just think it takes a long time, and thinking of how the questions go, you don't have time to be working out a load of things in a table. For this, I mean, there's only 5 figures, so it doesn't take very long, but even then it would be more beneficial to use the calculator. And then we want to interpret it. What do the statistics tell us? We'll do it later. So you can see 3 formulas here. They're all from the formula sheet. So they talk about sigma squared being the sum from I equals 1 to I equals k of fi times xi minus mu all squared over n. So that is a bit complicated to read it like that, but think of this phrase: the variance is the mean of the squared deviation. So I'll refer to this when I'm doing a calculation, but think of deviation as being distance from mean, or the difference between that and the mean. How far is it deviating from the mean? So the variance is the mean of the squared deviations. That's one. And the second one, it says sigma squared is the sum from I equals 1 to I equals k of fi xi squared over n minus mu squared. So I've written here, the variance is the mean of the squares minus the square of the mean. Now that will make a lot more sense when I actually do it. So what I'm going to do, I'm going to show you how to work out the standard deviation of the first list using the first method, the first formula, and the second list using the same. If you want to check that it works with the other formula, I would advise that, just to give yourself confidence. The standard deviation is the square root of the variance. So the signs here, the symbols here, little sigma, Greek letter, small lowercase s, that's standard deviation. Sigma squared is the variance. We will use these two, so mu and sigma, or mu is the mean, by the way. We'll use these two a lot more when we come to the normal distribution. That's where standard deviation and mean really make a lot more sense when describing distributions. Okay, so we've got 2 sets of data that we need to find the mean and the standard deviation of using a longhand method. We're going to use a slightly different longhand method, well, very different actually, for standard deviation for the second list. But hopefully it should all become clear how to do it. And you don't necessarily need to favour one over the other. You don't need to necessarily be able to do both. In fact, it's probably you're probably unlikely to have to do either. It's more likely that you'll lean on technology anyway. But I think it's good that you've seen the method. So we will start with the first one. So with this 3, 4, 6, 8, 11. Remember, this is before the library got a grant. The number of customers out of 20 asked who were dissatisfied with the range of books. So the mean, or x bar, or mu, is going to be, well, it's the sum of all of these divided by n. So it's literally 3 plus 7 plus 6 plus 8 plus 11, and divide that by 5. Well, the sum of all of those is 35. So 35 divided by 5 equals 7. So the mean equals 7. You need to start with the mean, whichever method you use, because then you use it for the rest. Remember, standard deviation is about telling you, it doesn't do this exactly, but if you think of it as the average distance from the mean of each value, how far away from the mean is each value, then that's really what you're talking about. So it tells you how spread out the data is. Right, so if we make a little table, so we've got our x, which is just the values, so 3, 7, 6, 8, 11. try again, 3, 7, 6, 8, 11, and then we want this x minus x bar, or x minus mu. If it's basically, this is distance from the mean. So what we're doing, these are the deviations, right? So how far away from the mean is it? We just subtract 7 from all of these values. So 3 minus 7 is minus 4. 7 minus 7 is 0. 6 minus 7 is minus 1. 8 minus 7 is 1. And 11 minus 7 is 4. Then remember, I said the variance is the mean of the squared deviations. So our next column is the squared deviations. It's the deviations squared. So we literally just need to square these numbers. And if you think about what's happening here, it's removing the negatives and positive numbers. The point of the squaring and then the square rooting that comes later is that it gets rid of these negatives. So if we kind of took an average of the deviations, it's just going to be 0. So 16, 0, 1, 1 and 16. Right. So we need the mean of the squared deviations. So sigma squared, the variance, equals the mean, as in the sum of all of these squared deviations, x minus x bar squared, over how many of them there are. So the mean of the squared deviations. Add them all up and divide by how many there are. Well, 16 plus 16 is 32, 33, 34. 34 over 5 is your variance. So your sigma must be the square root of 34 over 5, which comes out as 2.61. And if you think about units, by the way, it's exactly the same units as the mean. It's customers or dissatisfied customers. So it has a mean. There's a mean of 7 dissatisfied customers and a standard deviation of 2.61 dissatisfied customers. So after the grant, we're going to do this using the mean of the squares minus the square of the mean approach, but we're still going to need the mean. So so x bar, or mu, same thing, is going to be 2 plus 3 plus 5 plus 4 plus 6 plus 5 plus 4 plus 6 over 5, which is 5, 10, 20. 20 over 5 equals 4. So the mu equals 4. Then we're going to do the mean of the squares minus the square of the mean. Now the squares are literally the numbers squared. So if I had my x values, x is the actual number, so that can be 2, 3, 5, 4, 6. Then I want to actually just square those. So 4, 9, 25, 16 and 36. So actually you can see this is kind of, for this particular set of numbers, it would have been easier to do the mean of the squared deviations, but it's good to show you both. So now we need to find the mean of the squares, which means we add up all the squares, so sigma x squared, and then divide by how many there are. So that would be, if you add up all of these numbers, it comes to 90. So 90 over 5 is 18. So now we have the variance, sigma squared, equals the mean of the squares, so or 90 over 5, or 18. 18 minus the square of the mean. The square of the mean is the mean squared, so it's 4 squared. So that's 18 minus 16 equals 2. So the variance is 2. So sigma must be root 2, which is around 1.41. Okay, so now I'm probably not going to have room to write it, but I'll at least be able to say it. We need to tell us what this data means. So remember, the context of the question is, you've got a library. They surveyed their customers to see how dissatisfied, or how many people were dissatisfied with what they were offering in terms of books. They got some results, then they got some money and they bought a lot of books, and then they did the survey again. So really, we're trying to find out, have things improved? Have they not changed? Have they gotten better? Have they gotten worse? So before, so a bit more room. So we've got our mu, and that's the mean, and we've got the standard deviation, and we've got before and after the grant, that is. So before the grant, we had a mean of 7, so that's 7 dissatisfied customers out of 20, quite a lot, and a standard deviation of 2.61. After the grant, we had a mean of 4, so you can see in terms of the average, much better. Only 4 out of 16 customers, sorry, 4 out of 20 are dissatisfied with the range of books, and our standard deviation is also lower. So what this means is, and I would write it if I'd give myself room, so the average amount of dissatisfied customers has gone down, which is definitely a good thing. And this is illustrated by a lower mu. It's gone down by 3 customers per 20. And the standard deviation has also gone down. Now, standard deviation is a measure of spread, so it's saying like there's less variability, less variation in the customers. So remember, this was done on 5 different days of the week. So a higher standard deviation means that the range that you're offering on different days of the week could potentially be, it could be not as good, say on a Saturday. Well, sorry, it was a Saturday, it wasn't one of the days. But say you could go on a Friday and it's not as good, the range, as it is on a Monday. But the fact that this standard deviation has come down is very good news for this fictional library. Using technology, I'm going to show you how we can work out the mean and standard deviation of these 2 sets of data very quickly. So I'm going to do it for TI-84 and for a Casio. If you have an Inspire, I do apologise, I don't actually have one and I don't know how to do it, so you are going to have to work that out yourself, so sorry about that. I've put the numbers into the lists anyway, just to make it a bit quicker. I've sort of put them in ahead of time. So to do anything with stats, you need to go menu and statistics on the Casio. On the TI, you just need to go to stat and edit. I have put in the first distribution in list 1, so 3, 7, 6, 8, 11. And I've put the second one in list 2. You don't have to do it like that. I'm just doing it to save time, really. So once you've got that, we need to go to calc. So calc, and you need to go straight to setup before you press anything. Now, I'm going to work out the standard deviation and the mean of the first lot of data. So that was in list 1. If I just take you back to the table, that's list 1 there. So I need to tell it it's list 1, and that 1 is correct. This means that the frequency of each number in list 1 is 1. When that won't be 1 is when you're dealing with a frequency table, which will come a bit later. So I would just press execute, and I just press 1 there, but I'll wait for the TI. I need to go to stat and calc. 1 var stats, only 1 variable. It's the number of dissatisfied customers is the only variable in this. So I press 1 var stats. The list is L1, frequency list. Well, there is no frequency list, so I press enter, and calculate. For the Casio, I just press 1 var, so F1. And it's telling me X with a little bar on it is your mean, so that's your mu. So the mean is 7. And the standard deviation is where you can see the sigma X. It's 2.61 or 2 decimal places or 3 significant figures. And it's exactly the same value with the TI, which is reassuring. So this, you can see the little sigma sign, 2.61. So that's for the first list. Now, normally in practice, if you do it with 2 lists, you probably just go back to your table and write over the first list. But seeing as I already put it in list 2, so what I would do, I'd go back to setup, and I just tell it my X list, I'd change that to list 2. So I'd press list, and I would press 2, and then the 1 variable frequency is still 1, so that's fine. And then I would just press 1 var, And then I could see I've got a mean of 4 and a standard deviation of 1.41. So on the TI, I would press Stat and go across to Calc, one variable statistics. I just need to change that L1 to an L2. So second, L2's down here in 2. Look, change that to L2. There is no frequency list. Yes, calculate. And it's the same numbers X bar. The mean, the mu is 4. And the sigma x, the standard deviation, 1.41.